Figure out how to get that off the screen now. I updated and now I got that stuff on there. Okay, all right. So today, we are not using a calculator. You're taking notes in your own notes. Starting a new, fresh unit today. Right now the plan is to take the test on this on the 13th of November, which is 1, 2, 3 weeks from tomorrow. Yep. So the schedule on the back of the room has been updated. We're a goofy schedule today, so we are out of here at 9:28. Okay. So I got 32 minutes, which is more than enough time to get done what we get done. A lot of today is going to be visual. Some is going to be on your notes. The only thing that I ask is that when it's visual, that you're paying attention up on the board because it's visual, and you're going to need to know all this stuff. Last class, they got the ire of Lynn's, and I just stopped because they weren't paying attention. They were doodling. They were not even looking up at the things that I was doing on the board. So kind of got the ire. Yeah, I get it. That's using the old brain. Okay. All right. So yeah, and then we should have some time at the end then too. Okay. So we are going to shift from a trigonometric ratio like sine equals opposite over hypotenuse. Okay. Tan or cosine equals adjacent over hypotenuse. We're going to shift from those thinkings of a triangle to thinkings as a function. Okay? So now we're going to go with the function f of x equals sine of x. F of x equals cosine of x. We're going to shift into that. And what we're going to do with those is we are going to be graphing. We are going to be hardcore graphing for the next 3 weeks and 1 day. Okay? You are going to translate and transform these functions using using 4 different transformations. Okay? So first off, before we get into translating and transforming these functions, we should talk about the functions in terms of their inputs and their outputs. So an independent variable, remember, is the function's input. Okay? So in this function, we are going to be inputting an angle. And yes, 9 times out of 10, actually probably 9.44 times out of 10, that angle is going to be in radians. Last unit we were heavy in degrees. This unit we are going to be almost 100% in radians. Okay? That would go full 100% because then if I had an example, they would say, you said we weren't going to. No, it's almost. Okay? Right? So our input, what we're putting into our function, the x value that's going in is going to be an angle. Okay? The output, what we get out from our function after we put it through the function machine, okay? That output is going to be a real number. What is that real number on either one of these functions? What is that real number going to be in between? -1 and +1. It was obviosity number 1. Okay? All the values of sine are in between -1 and +1. All the values of cosine are in between -1 and +1. Remember, here on the unit circle, if we have sine, that's our verticalness of it. It's got to be in between. The smallest it can be is -1. The biggest it can be is +1. X's is the horizontal. Once again, smallest it can be is -1. Biggest it can be is +1. So that real number that we get out is going to be in between -1 and +1. Now, that can change. Okay, that's just on the parent functions. F of x equals sine of x, and f of x equals cosine of x. Just on that function, or those two functions, does that hold. Because if we vertically shift, which we will be able to do, if we vertically shift our function, now we're outside of that range. And that's okay, because we added something to the function. Okay? If we vertically stretch that function, that's okay, because we added something to that function. And this is just for that parent function. Okay? All right? So, I'll give you a couple of minutes here. Actually, I'll give you like a minute to write down these two functions. These are the functions with the 4 shifts in them. F of x equals a sine or cosine of the quantity b times the quantity x minus c, then plus d. Or I should say then plus d. So those 4 shifts, A, B, C, and D. I shouldn't say shifts. I should say transformations, okay, or translations, or tweaks, if you will, to the function. Those 4, each of them has something different. For instance, A here is your vertical stretch. Okay. So that's going to be able to take your function and it's going to be able to stretch it out farther than 1 or -1. Okay. It's also going to, you could also compact it less than 1 or -1. So we can, that's going to be our A is going to stand for amplitude, and we're going to learn all about that on Tuesday of next week. What it also does is it also is a flipper. Okay? It will flip your function over. Okay? And we'll show you that here momentarily. B, first off, it sets the period. These functions are wave functions, and they never stop in either direction. Okay? So the B value sets how frequently that wave happens. Okay? That's the period. How the amount of time it takes to get back to the exact same spot in the exact same location on the graph. Okay? We are only going to graph, we're not going to graph the whole period, or I shouldn't say the whole period, the whole function. We are only going to be graphing one period. and we're going to call that the first lap wave. We're going to ask you to go one time around the unit circle and translate and put that on the graph. Okay? And it seems like a lot of work, but you'll get the picture real fast. Okay? The other thing that B does is if B is negative, then that also flips a sine function. It doesn't flip a cosine function. That again was an obviosity, that cosine of negative theta is equal to cosine of theta. Okay? That part doesn't flip, but sine of negative theta is equal to negative sine of theta. That was, I think, obviosity 2 or 3. 2 or 3, that was obviosity. Okay? C is going to be your horizontal shift. It's going to take the start of your first lap, instead of it being at 0, 0, the origin, or 1, 0 for cosine, it's going to take that and it's going to slide it to the left or to the right. Okay? It's going to be your, typically we will call it the start value because it's where your function is going to start. Okay? Right? And we'll get into that more next week, Thursday. And then lastly, we have D, and D is your vertical shift. It's going to take your whole wave and it's going to move it up or down depending on its positivity. Now, the nice thing about D is D you think about straight up. Okay? If D is negative 5, you move your graph down 5. If D is positive 17, you move your graph up 17. With C, that you got to think oppositely because C is inside a set of parentheses. So C you think oppositely. You see minus pi over 2, that means you're going to shift your graph to the right pi over 2. Okay? You see plus pi there, you're going to shift your graph to the left pi. Okay? You think oppositely inside parentheses. Okay? So let's put all of this to work. Now, this next part here now it becomes a visual. Okay? So you can honestly put your pencils down and just pay attention up here. Okay? So this right here, what we have graphed, is the first lap of the sine function. Okay? Truly, the sine function looks like that. Okay? It goes on forever and ever and ever in both directions, never getting above 1, never going below negative 1. Okay? Repeats that. It's a repeated function, if you will. Okay? But we're just focusing in, you would only have to graph what we call the first lap wave. So this is from 0 to 2 pi. Okay? Cosine looks like that. The cosine function, that would be the whole entire cosine function. But again, we're just asking you to graph the first lap of that function. Okay? Now, we'll go back to the sine graph. Oops, that gave me just sine. I thought it had the floater in it. Didn't have the floater in it. Okay, so then we'll go to here. So now we'll go to here. So here is the sine function. Again, you would only have to graph, you can't really see it because they're the same color. You would only have to graph the first lap, which would be from here to here. Actually, tap the brakes. Let me show you sine and cosine on the same graph. Oops, they're both sines there. That's why. We'll go here. Oops, not that one. This one. There is sine and cosine on the same graph. Okay? Do we notice anything about those two? If we shifted them a little bit, they would be one on top of the other. Yep, exactly. Okay, I would concur. They follow the exact same motion, same pattern, all that good stuff. Cosine is just shifted pi over 2 to the left of sine. So let me get cosine off of there now. Okay, so here we go. What do I got until, what did I say, 9:28? Plenty of time. Okay? So with A values, okay, the larger my A value gets here on sine, the higher up on the graph my sine function goes. So if my A value is 5.5, I would go up to positive 5.5, and I would go down to negative 5.5. Okay? All right. Let me reset that one. Oh, if it's negative, so here's back to, there's back to normal. Now if I go negative with it, it flips itself over, and instead of going up and to the right, now it's going down and to the right. Okay? So it literally flips itself over. It rotates it, or not, yeah, I would say rotate. It would reflect. I had to get my geometry one down. It would reflect in the x-axis. Okay? So let's get this back to just 1. Okay, so we're back there. Okay, so then the B value we said was the start, or excuse me, was the period, if you will. Okay, so let me get back to just one sine. So this would be one period of it. It gets me back to the same spot, which would be a 0. Yes, this is a 0 here, but it's a 0 while the function is decreasing. This 0 was when the function is increasing, so it puts me back at the same spot. Okay? So that's one period of a sine graph. Now, if I change this, I get more and more and more waves, or periods, if you will, because I don't think I can draw on, maybe this will allow me to draw on it. So here, nope. So I go from that one, so from here to here is now the period. So now my period is 2 pi over 5 instead of just 2 pi. And because it's sine, if we go negative with it, it also reflects it in the x-axis. And again, the larger the number we get, or the larger the absolute value of the number we get, the more graphs, the more waves you would get, the shorter the horizontal distance would be for it. If we get less than 1, it stretches it way out horizontally. Okay? Bigger absolute value would compress it, kind of like an accordion. I always refer to this one as the accordion. Okay? So here you're pushing in so the sound comes out. Here you're pulling it away so the air goes back in. Okay. Now, our C value is, I don't know if when I adjust the C value, if that dot will stay on there or not. Okay, so we're watching this dot right here. So my C value, as I become positive, that dot shifts to the right. As I go negative, that dot shifts to the left. Okay? But again, we'll talk about this next week. That C value can change, but you think about it oppositely in the actual function. Okay? You get that C value back to 0. Okay? Then our D value, that's going to be a vertical shift, and that's going to be, again, straight up. Positive makes it go up. Negative makes it go down. Okay? Whoa. No, I don't want to add a slider. Okay? So when it's all said and done, we're going to combine all 4 of those. So we might give you a function along the lines of A is -2. B is pi divided by 2. Okay? C is pi divided by 8. And D is -1. And you would graph that function. You would just graph the first lap of it. Just gives me the intercepts. Okay, so this would be D is -1. So you would just give me this. So if you follow my finger here, you would just give me this right there. That would be the function that you would graph out of that. Okay? Good times. But again, we are just dipping our toes in this today. We will go in depth into this next week. Any questions?